Okay, now that we've discussed the definitions for symmetry, let's talk about how we can test for symmetry. Okay, so if you've been given a graph and you think about it like the folds of paper, it's easy to see where your symmetry will occur if you've already been given the picture. But if you haven't and you need to find your symmetry algebraically, you're going to need to follow these steps. Okay, so if you are testing to see if your graph is symmetric with respect to the x-axis, the first thing you're going to do is you're going to replace y with negative y in the equation and simplify. If an equivalent equation results, the graph of the equation is symmetric with respect to the x-axis. Okay? If you are asked to test if your graph is symmetric with respect to the y-axis, you're going to do the opposite. You're going to replace x with negative x in the equation and simplify. If an equivalent equation results, the graph of the equation is symmetric with respect to the y-axis. Okay? And the last type of symmetry you could test for is with respect to the origin. So if you're testing if it's symmetric with respect to the origin, you need to replace both of your variables. So you're going to replace x with negative x and y with negative y in the equation and simplify. If an equivalent equation results, the graph of the equation is symmetric with respect to the origin. Okay, so we're going to do an example where we're testing for these types of symmetry. When you're doing these tests, they may ask you if it's specifically symmetric with respect to one of these categories, either the x-axis, the y-axis, or the origin, or it may just ask you to find them all. The order in which you do these tests doesn't matter. So just out of habit, we normally test for x, y, and then the origin. But if you wanted to test them in a different order, it wouldn't mess with your results. Okay. So let's see if we can do this particular problem. So this problem says test an equation for symmetry. And it says test y equals 4x squared over x squared plus 1 for symmetry. Okay. So like I said, it does not matter the order in which you do the test, but I'm going to go ahead and follow those steps that they gave us. So I'm going to see if my graph is symmetric with respect to the x-axis first. Okay. So remember, if you're testing for that symmetry, you are going to plug in. All right, you're going to replace y with negative y. Okay. So everywhere in this equation where I see a y, I'm going to replace it with negative y. All right, so let's do that. We have negative y equals 4x squared over x squared plus 1. Now, once I do the replacement, I need to make sure that I've simplified everything here as far as it can be simplified, and then I'm going to do a comparison. So when I look here, negative y, there's nothing I can do to simplify that, and the right-hand side is already simplified as far as it can go. So what I'm doing is I'm comparing this new equation that I have to the original, okay? And we're checking to see if they're the same. So as I'm looking at this, okay, it is not the same as my original equation. All right, my original equation says y equals 4x squared over x squared plus 1. But this new equation that I created says negative y equals 4x squared over x squared plus 1. They are not the same. So what I can say is that no, this is not symmetric. I can say no, my graph is not symmetric with respect to the x-axis. Okay, in order for it to be symmetric, my new equation would have to be the same. It would have to be identical to my original one. All right, so since that didn't work for me, I'm going to go ahead and test to see if it's symmetric with respect to the y-axis. Okay, so if I'm testing to see if my equation is symmetric with respect to the y-axis, I'm going to replace x with negative x this time. So everywhere I see an x in that equation, I'm going to make it negative x instead. So I have y equals 4 times negative x squared over negative x squared plus 1. All right, and I'm going to do any simplification that I can do. So I do know that if I have a negative and it's squared, it becomes positive. So this is going to become x squared. So this becomes y equals 4x squared over. Same thing's going to happen in the denominator. So I have negative x to the second power. It's going to square. This is going to come positive, and I'm going to have x to the second power plus 1. Now I need to see, is my new equation the same as my original one? When I compare them, they are identical. So that lets me know that yes, my graph is symmetrical with respect to the y-axis. Awesome. So the last one that I have to test for is the origin. All right, let's see if I can get some more space. There we go. All right, so the last one I have is the origin. If I am testing for the origin, I am replacing both of my variables. So I'm going to replace x with negative x and y with negative y. So that means everywhere in that equation where I see an x and a y, I'm going to replace them with their negative counterparts. So I have negative y equals 4 times negative x squared over negative x squared plus 1. I'm going to do the simplification. That left-hand side is not going to simplify any farther, but I do know that right side does simplify. Okay. And now I'm going to compare this equation that I just found with the original. Okay. As you can see, again, they are not the same. The original has positive y equals the right-hand side, and my new equation has negative y equals the right-hand side. So they are not the same. So for this problem, I have to say, no, my graph is not symmetric with respect to the origin. Cool. So when you are doing these tests for symmetry, you're never going to know which one your graph is symmetric to unless you have a picture. So you're going to have to test all three of them unless your problem prompt specifically asks for just one type of symmetry. Okay, so let's go ahead and check our solutions. All right, so we were correct. It was not symmetric with respect to the x-axis. It was symmetric with respect to the y-axis. Awesome. And it was not symmetric with respect to the origin. Cool. So if we were actually to graph this picture, this graph, it would look something like this. So with the picture, we can easily see that it is symmetric with respect to the y-axis, because if you were to fold your graph along the y-axis, both halves of that graph would match up. Awesome. We're all set, and you're good to go.